Welcome to our lab lesson. Today we are going to speak about special experiment. This experiment called as titration process. The titration process very well known in the chemistry. Let's look the basic principle of the titration. During the experiment, the titration experiment, the measured or determining the known concentration of special example sodium hydroxide with known concentration which required to neutralize the known amount of the acidic in the mixture. During the chemical reaction, during this experiment, we will encounter some terms. Let's pay attention to these terms. Burette, titrant, standard solution, unknown, indicator, and end point. What is the burette? The burette, the technique is used to measure the volume. We add to the burette the titrant. What does the titrant mean? Titrant, compound, special compound. When we add into the unknown acidic solution to make the neutralization reaction. Standard solution. What are the standard solution? Standard solution is known concentration of the solution. Unknown compound or mixture that known the concentration. We don't know the concentration. Indicator. Indicator, there are a lot of kind of the indicator which we use in the chemical reaction, during the chemical reaction. And we add small amount of the indicator in the reaction medium, and it indicates that the reaction complete by changing the color. End point. What does the end point mean? End point, the special stage in the titration process. This show that or indicate that the reaction complete by changing the color. Assume that the titration process we apply for the neutralization reaction. Assume that the unknown sample monoprotic acid we add in this solution in the water and make the solution, but we don't know the exact concentration of the this solution, and after that we add a few drops of the indicator phenolphthalein, and pour drop by drop from the burette into this solution, sodium hydroxide solution. And this process going up to when the color change by pink. Why? Because in the acidic medium, in the phenolphthalein, our indicator is the colorless. When this reaction mixture is changed to the pink, it means that the reaction is complete. Now let's do the procedure experiment part. Now, a few minutes ago, we gave the brief information, the theoretical part of the titration process. Let's do the experiment. For this experiment, we need several techniques, compound and equipment. For example, for this reaction, we need standard solution. Our standard solution, our instructor make the solution. This is basic solution, sodium hydroxide solution, and we know the concentration of this solution. Also, our instructor made the acidic solution, unknown monoprotic acidic solution. And also, we need to observe the reaction complete or not. That's why we must add the indicator. Which kind of the indicator we must need? We must need the phenolphthalein. Please give me the phenolphthalein. Yes, and this is solid state. And please give me the solution. And don't worry. We have another dropper one. This is phenolphthalein, and phenolphthalein is the white solid in the normal condition, in the solid state. If we want to obtain, to produce the phenolphthalein solution, we add a very small amount of the phenolphthalein into the alcohol, and we make the phenolphthalein solution. Now, for our experiment, we need to start our reaction, and this is our burette. We must add to our burette our standard solution. Before the reaction, I want to mention that all of the equipment should be clean and dry. I repeat again, all of the equipment should be clean and dry. We should now I pour our standard sodium hydroxide solution into the burette container. We know the concentration, and we know these substances in the concentration, and let's pour burette with this solution. Pay attention here. The burette is 5 milliliter. I'm sorry. Please help me. Wait a minute. Wait a minute. When our liquid reaches the end point. Wait. Wait. Again. Thanks. Now we have 50 milliliter. Now we have 15 milliliter of sodium hydroxide solution, which we know the concentration exactly. Now our standard solution is ready for reaction. Now we must take unknown acid solution. This our unknown acid solution in gradient cylinder. We should pour in the beaker. Let's cover this one. Now I want to take 3 milliliter of unknown acidic solution. This is enough for our experiment. First, it's and 1.5 milliliter, and also now in the Erlenmeyer we have 3 milliliter of unknown acidic solution. Now we must add. Where is the dropper? Please give me the dropper. Our dropper here. We must add a few drops of the indicator. 1, 2, 3, 4. Enough. Now this is enough. This indicator, and let's start the reaction. And we know exactly the molarity of the titrant. Our reaction reach to the end point at a few drop of sodium hydroxide is enough. And here let's calculate the volume of the sodium hydroxide solution, we use for this reaction approximately accuracy this 10 milliliter of sodium hydroxide solution. And after the 10 milliliter of sodium hydroxide solution, our reaction is complete. Our reaction is complete. Now, after this point, we need to calculate our unknown acid concentration, and that's why we need the whiteboard. Now, let's calculate our unknown acid concentration. From the experiment detail, we obtained that our sodium hydroxide solution titrate equal 10 milliliter, and concentration, our instructor tell us the concentration of the sodium hydroxide solution, standard solution, equal how many? 1 molarity. Also, let's calculate the mole of the sodium hydroxide. Use the molarity equation and the molarity multiple volume divided this one. This called how many? 0.1 times 10 divided 1000. This equal 0.001 mole sodium hydroxide. In our experiment, we use 0.001 mole sodium hydroxide. Let's look at the reaction. As I mentioned, in our reaction, unknown acid is monoprotic. That's why the reaction 1 mole acid react with the 1 mole sodium hydroxide. But 0.001 mole sodium hydroxide also react with the X mole unknown acid. We can calculate this equal how many? 0.01 mole unknown acid. And in the final step, we should calculate the concentration of the unknown acid. That's why we need this equation. Our amount of the mole unknown acid equal how many? 0.001 times 1000 divided how many? 3 milliliter. As I mentioned, in our reaction we took 3 milliliter of unknown acid. This equal 0.333 molarity. And final steps, dear student, in the final step we found that our unknown monoprotic acid concentration equal like this. Thanks for watching. Bye.